Let's start with our paper 2 in electric potential and capacitance. First question here says two charges 3 into 10 to the power minus 8 coulomb and minus 2 into 10 to the power minus 8 coulomb are located at 15 centimeter apart. The point on the line joining the two charges at which the electric potential must be 0. Let's see. So first of all, let me place here our first charge. Okay, this is our 3 into 10 to the power minus 8. And another one here minus 2 into 10 to the power minus 8 coulomb. Okay, and what is the separation between them? The separation between them is 15 centimeters, so 15 into 10 to the power minus 2. Now they are asking, we have to find the point at which the electric potential is 0. So let's assume that this is our point P where the electric potential is 0 and this point P is at a distance of x. So if it is at a distance of x centimeter, then from the other side it will be at a distance of 15 minus x, right? Okay, because the total distance is 15 centimeter. Now, first of all, we will find potential. Let's call it as charge at A and let's call it as charge at B. So let's first find the potential at point P due to A. That will be equals to K, which is 9 into 10 to the power 9. Q, the charge on A is 3 into 10 to the power minus 8, whole divided by the separation. What is the separation? X centimeter. So we can take it as x into 10 to the power minus 2. Correct? That will cancel out eventually. So this is our equation 1. Now potential at P due to B, that will be equals to 9 into 10 to the power 9. And what is the second charge? Be very careful, you have to consider the negative sign here. Why you have to consider? Because the potential is a scalar quantity and negative sign is very important. Okay, so here it will be 15 minus x. Okay, so let me write it 15 minus x here into 10 to the power minus 2. Now the net potential there is 0. So which means at point P the net potential will be what? VPA plus VPB, and that is equals to 0. So here VPA will be 9 into 10 to the power 9 into 3 into 10 to the power minus 8 whole divided by x into 10 to the power minus 2, and this is equals to 9 into 10 to the power 9 into how much? Now since I have taken VPB on the right hand side, okay, this negative will convert into positive, or let me just write here only. So let me add here plus minus 2 into 10 to the power minus 8 whole divided by 15 minus x into 10 to the power minus 2 equals to 0. Now this, when it goes on the right hand side, the second parameter, when it goes on the right hand side, what it will do, this parameter will convert into positive. This negative sign will convert into positive. So this will give you here 9 into, let me scroll little up, 9 into 10 to the power 9 into 3 into 10 to the power minus 8 whole divided by x into 10 to the power minus 2, that is equals to 9 into 10 to the power 9 into 2 into 10 to the power minus 8 whole divided by 15 minus x into 10 to the power minus 2. Correct? Now we can cancel out the terms, like 10 to the power minus 8 will cancel with 10 to the power minus 8, 10 to the power 9 will cancel with this, and 9 also cancels with 9, and 10 to the power minus 2 cancels with 10 to the power minus 2. What we left with here is 3 upon x, and here we left with 2 upon 15 minus x. Let's cross multiply. It will be 15 3s are 45 minus 3x is equals to 2x. Let's take this minus 3x on the other side. It will be 45 equal to 5x. So when you divide 45 by 5 is 9 centimeter, that is equals to x. At 9 centimeter, the potential is 0. Let's see if there is any option. Yes, option C is correct for question number 1. Let's move to question number 2. Question 2 says two charges 4 microcoulomb and minus 2 microcoulomb. So let me draw here. This is our 4 microcoulomb and this is our minus 2 microcoulomb. They are placed at 15 centimeter apart. So this separation is again 15 centimeter between them. Okay. The point on the line joining the two charges at which the potential is 0. So we have to again find the same thing. We have to find at any point, let's say P, the potential is 0 due to charge A and due to charge B. Let's say this is x, this will be 15 minus x, correct? And into 10 to the power minus 2 because they are in centimeters, right? So first of all, potential at point P due to A, that will be K Q at A, which is 4 microcoulomb, 4 into 10 to the power minus 6, whole divided by separation x into 10 to the power minus 2, because it's in centimeters, right? So potential VPA is done. VPB, potential at P due to B, will be 9 into 10 to the power 9. And what's the charge here? Minus 2. So you have to take the sign because it's a scalar quantity, whole divided by separation, which is 15 minus x into 10 to the power minus 2. Now, next is what? Next is potential, net potential at point P will be equals to potential PA plus PB. Correct? Now, potential due to PA will be 9 into 10 to the power 9 into 4 into 10 to the power minus 6, okay, whole divided by x into 10 to the power minus 2. Plus, but here due to this negative sign, we will have minus 9 into 10 to the power 9 into the charge is 2 into 10 to the power minus 6, whole divided by 15 minus x into 10 to the power minus 2. Now let's take it on the other side. One of them will become positive. So 9 into 10 to the power 9 into 2 into 10 to the power minus 6, whole divided by 15 minus x into 10 to the power minus 2. That is equals to 9 into 10 to the power 9 into 4 into 10 to the power minus 6, whole divided by x into 10 to the power minus 2. Next, what we have to do? We have to cancel out the common terms. So 10 to the power minus 6, 10 to the power minus 6, 9 into 10 to the power 9, 9 into 10 to the power 9, and 10 to the power minus 2 with 10 to the power minus 2. You left with 2 upon 15 minus x, and here you left with 4 upon x. When you cross multiply, it will give you 2x is equals to 15 4s are 60 minus 4x. Now taking 4x on the other side, it will be 6x is equals to 60, or x is equals to 10 centimeter. That's our correct answer. Okay. Now let's see what's the correct answer here. 10 centimeter. That is option A for question number 2. Let's move to question number 3. Question number 3 says two charges, this and this are this. Okay. Again, you have to do the same thing. So the point on which the potential is 0. So quite similar to previous two questions. This is our, again, if you have not understood, pay attention, 8 nanocoulombs. And this is our minus 2 nanocoulombs. Okay. Both are separated by what distance? They are separated by a distance of 15 centimeter. Correct. And the charge, let's call it as A here. Let's call it as B. And let's say at point P, the potential is 0. Let's say this is at a distance x, and that is 15 minus x. I hope this is clear. Okay. Now, potential VPA will be equals to potential at P due to A will be K, which is 9 into 10 to the power 9 into charge, which is 8 nano. Nano, in case if you don't know, it's 10 to the power minus 9, whole divided by the separation x. Okay. Because anyway, centimeter will cancel out. I am keeping it at x only. Potential VPB. Okay. VPB, that will be 9 into 10 to the power 9. And what's the charge? Be very careful. Negative sign. Again, I am saying it's a scalar quantity. So you have to take the negative sign. 15 minus x. Correct. Now, what we will do? We will add them. So, net potential at P will be VPA plus VPB. And this is 0, right? Equals VPA, 9 into 10 to the power 9 into 8 into 10 to the power minus 9 whole divided by x. Minus 9 into 10 to the power 9 into 2 into 10 to the power minus 9 whole divided by 15 minus x. Now, if I take this second term on the left hand side, it will be 9 into 10 to the power 9 into 2 into 10 to the power minus 9 whole divided by 15 minus x. And that is equals to 9 into 10 to the power 9 into 8 into 10 to the power minus 9 whole divided by x. Now, let's cancel out the common terms. So, 10 to the power minus 9, 10 to the power minus 9, 9 into 10 to the power 9 and 9 into 10 to the power 9 cancels. We left with 2 upon 15 minus x is equals to 8 upon x. When you cross multiply, it will be 2x is equals to 15, 8 into 15 minus x. So, 2x is equals to 15, 8 5s are 40 and 8 4s are 8 and 4, 12 minus 8x. So, this will become our how much? 10x is equals to 120 or x is equals to 12. So, that must be our answer. Let's see the correct answer. So x is equals to 12 centimeter. Option B for question number 3. Let's move to question number 4. Two charges 30 microcoulomb and 15 microcoulomb are located 12 centimeter apart. We have to find the potential being 0. So let's do it again. Let's place our first charge here, 30 microcoulombs. So 30 microcoulombs at any point A, and another point here is 15 microcoulomb at any point B, and this is 12 centimeter apart. Correct? Now they are saying at any point P the potential is 0. Let's say that point is at a distance of x centimeter. So from here it will be 12 minus x. Correct? Potential at P due to A in this case will be K. Charge on A 30 micro, in case if you don't know micro, 10 to the power minus 6 upon separation x. Potential VPB will be K, and be very careful, you have to take the sign. So here it is 15 only, so 15 into 10 to the power minus 6 whole divided by separation is 12 minus x. Correct? Now VPA plus VPB, that will be how much? 0. So potential VPA plus VPB is equals to 0. Correct? So what is VPA? So VPA, I am taking it is equal to VPB straight away minus. Okay? So VPA will be how much? 9 into 10 to the power 9 into 30 into 10 to the power minus 6 whole divided by separation, which is x, equal to minus VPB. What is VPB? 9 into 10 to the power 9 into 15 into 10 to the power minus 6 whole divided by separation, which is 12 minus x. Now let's cancel out here 9 raised to 10 raised to 9, 9 raised to 10 raised to 9, and 10 to the power minus 6 with 10 to the power minus 6. What we left with? 30 over x is equals to minus 15 upon 12 minus x. Correct? When you cross multiply, this will become 30 into 12, 0, 3 2 is 6, and 360. Correct? And this will be minus 30x, and here it is minus 15x. Minus 30x goes on the right hand side, it will become 360 is equals to minus 15x plus 30x. So this will be 15x, that is 360. Correct? Now 360 over 15, that is equals to x. So let's simplify. This will become over here after cancelling 5 3s are and 5 1s are 5, then 5 7s are 35, and 10 72. So 3 cancel, 3 2s are 6. Okay, and this will be 12. So 24. So we are getting here x is 24 centimeter. Okay, and that is, I think, is not an option. Okay, so option D is correct in this case, which is none. Let me recheck our calculations. So 360 upon 15 is 5 7s are 35, 5 2s are, and 5 3s are, and 3. Yeah, so none is the correct answer for this question number 4. Let's move to question number 5. The electric potential at the center of a square of side root 2 meter having charges this at the 4 corners is. So we have to find the potential. So let me first draw a square. Okay, try to make it a square. So this is our square, and on this square we have at different corners our charges. So first one is 100 microcoulombs, minus 50 microcoulombs, okay, 20 microcoulombs, and this is minus 60 microcoulombs, right? And each side of the square is how much? Root 2 meters. Okay, let's name it A. Okay, let me name it with a different color first. So this is our A, this is B, this is C, this is D. Okay, now they are asking our center at O. So we have to find potential at O. Okay, so if the side is first we will find AC. So AC square equals to AB square plus BC square using Pythagoras theorem, right? Because this side, okay, that will be the hypotenuse of this triangle ABC, right? So AC square is AB square plus, what is AB? Root 2. So root 2 square is 2, and BC square, root 2 square is 2. So it will be 4. So AC square is 4. So AC is nothing but 2. So if our AC is 2, what will be our AO? Sir, AO will be 1. Correct? 1 meter, and that is also equal to BO. This will be equal to CO, that will be equal to DO, correct? All are 1 meter. I hope this is clear. If they all are 1 meter each, then we can find the potential. Let's find the potential. Potential V, okay, due to A at O will be equals to K Q1 upon AO, correct? Potential VBO will be equals to K Q2 upon BO. Similarly, potential at CO will be K Q3, the charge at C, upon CO, and VDO will be equals to K Q4 upon DO. Now what is K? Sir, K here is 9 into 10 to the power 9. What's the first charge? 100 microcoulomb. So it will be 100 into 10 to the power minus 6 upon AO, which is 1. Similarly, KQ2 will be 9 into 10 to the power 9 into 50. So positive or negative? Minus. So you have to consider the negative sign. Minus 50 into 10 to the power minus 6 because of microcoulomb, whole divided by 1. Similarly, 9 into 10 to the power 9. What's the separation? 20 into 10 to the power minus 6 whole divided by 1. And VDO will be finally 9 into 10 raised to 9 into minus 60 into 10 raised to minus 6 whole divided by 1. So net potential at O will be the sum of VAO, superposition principle we are using. We are adding directly all the potentials, okay? And we know here what are the common parts. You can see 9 into 10 to the power 9 is rising in all the terms. 10 to the power minus 6 is rising in all, and upon 1. So upon 1 we can ignore because anyways they are divided by 1, will not make any difference. So 9 into 10 to the power 9 common into 10 to the power minus 6 common. We left with 100 minus 50 plus 20 minus 60. So here we got our answer as 9 into 10 to the power 3, and in the bracket 100 minus 50, 50 plus 20, 70 minus 60, 10. So this will be 9 into 10 to the power 4 volts. This is the potential at the center of the square. Let's move to question number 6. The work done in moving a charge of 3 coulomb between the 2 points is 6 joules. So charge here is 3 coulombs. Work done, which is stored as the potential energy of the system, is 6 joules. The potential difference between the 2 points they are asking. So we know that the charge potential energy is equals to charge into potential difference. Direct question. U is 6 joules. Q is 3 coulombs into VAB. So VAB here will be 6 by 3, which is 2 volts. So correct answer is option C, 2 volts. Clear it is? Let's move to our next question, question number 7. So question number 7 says, the electric potential at 0.9 meters, so R is equals to 0.9 meters, from a point charge is, potential is 50 volts. The magnitude of the charge they are asking. So we know that V equals to K Q by R, or you can say, taking everything on the other side, you can take Q is equals to how much? V into R upon K. So let's substitute here. What is V given here? 50 into R. R is how much? 0.9 whole divided by 9 into 10 to the power 9. Let's remove this decimal point here. We will get an extra 10, and 9 cancels with 9 and 0 cancels with this. We left with 5 into 10 to the power minus 9 coulomb. So correct answer is 5 into 10 raised to minus 9, option C. Let's move to question number 8. Question number 8 says the electric field at a point due to a point charge is 20 Newton per coulomb. So electric field E is 20 Newton per coulomb. And the potential V is 10 joules per coulomb. The distance of the point from the charge. So we have to find R. We know that electric field into R is equals to potential. So R is potential V by E. And what is V? 10 and E 20. 1 by 2. 0.5 meters. Correct option is option C. Let's move to question number 9. 2 point charges Q and minus 2Q are kept at a distance D apart. So let's roughly draw it. This is Q, this is minus 2Q. Separation between them is D. The location of the point relative to charge Q at which the potential due to the system of charges is 0. So let's say this is P point and this is X centimeter. If this is X, what will be this? D minus X, correct? This is charge at A, this is charge at B. Let's find the potential. So potential P due to A will be equals to K first charge Q upon X. Potential at P due to B will be K, and what's the charge? Minus 2Q upon D minus X. And what is the net potential at that point? Net potential at point P, which is sum of VPA plus VPB, is how much? 0. So let's put here 0 equals KQ by X minus 2KQ by D minus X. Let's take this 2KQ on the left hand side. 2KQ upon D minus X is equals to KQ by X, correct? Let's cancel out the common terms. So here KQ will cancel out with KQ, and let's cross multiply. So 2X is equals to D minus X. Taking X on the other side, 3X is equals to D, okay? And X is equals to D by 3. So 1/3 of the distance. At that point the potential will be 0, okay? So here the correct answer is D by 3, option B. Let's move to our question number 10. The electric field between two metal plates 3 mm apart. So distance here is 3 mm, 3 into 10 to the power minus 3 meters, connected to a 12 volt battery. So voltage here is 12 volt. We have to find electric field. So E into D is equals to V. So E will be equals to V upon D. What is V? 12. And what's the separation? 3 into 10 raised to minus 3. So cancel out 12 and 3, 4, and 10 to the power minus 3 goes up 3. Okay, that is volts per meter. So 4 into 10 raised to 3 volts per meter. That is our option A.